Hi everyone. This is our look at the organization of the acid-base table, which you can find in the data booklet on pages 8 and 9. It's divided up into strong and weak acids and strong and weak bases. Here we go. Strong acids, the definition is that they dissociate completely. Remember, we have this modified Arrhenius definition now that acids, all acids, whether they're strong or weak, are proton donors. Strong acids dissociate completely. They fully donate every proton that they have. They're excellent donors. We find them above the gray bar on this table of the data booklet. There's 6 of them. Perchloric, hydroiodic, hydrobromic, hydrochloric, sulfuric, and nitric. These 6 at the top are strong acids. They're all equally strong. Weak acids do not dissociate completely. We find them below the gray bar, and here they're in order of decreasing strength. They get weaker and weaker as we go down. The lower, the weaker. Above the gray bar, these 6 at the top are strong acids. They're all equally strong. So the order of these 6 up here at the top is irrelevant. However, the majority of the table are weak acids. And that means they all have something in common. They all do not dissociate fully. They all are bad proton donors. They give some protons but hang on to some. They don't completely give up their protons. They're all weak, but they're ranked in order of decreasing strength. So here at the top, it sounds a little bit strange to say, is oxalic acid. It's the strongest of the weak acids. And then they get weaker and weaker and weaker as we go down, weaker and weaker as we go down, till we get to the very bottom, and the weakest acid of them all, water. On the right-hand side of the table, we have our bases. It's basically the same idea. Strong bases dissociate completely. They fully accept protons. Here, it's only the gray bar at the bottom. Here, there's 6 strong acids at the top, but it's just this one line of the table that contains hydroxide ions that are strong bases. Weak bases also do not dissociate completely. They're bad proton acceptors. They don't fully accept their protons. They're above this gray bar, above the gray bar this time. This time they're also in order, but it's going up the table. Right above the gray bar is the hydrogen phosphate ion. It's not the gray bar itself. It's higher up than the gray bar. It's in the weak range, but it sounds a little bit funny to say. It's the strongest of the weak bases. And then as we move up the table, they get weaker and weaker and weaker as we go up, and weaker until we reach the very weakest one of them all, water. Strong acids above the gray bar, weak acids below the gray bar, but put in order of decreasing strength going down. On the base side, just the gray bar, just hydroxide ions are the strong base. The bulk of the table are weak bases, but this time they get weaker and weaker as we go up. This also shows us that water is amphiprotic. It's here in the acid column at the bottom. It's the weakest one. And it's in the base column up at the top, the weakest one. It's in both columns. It's amphiprotic. The organization of this table is really important. We're not going to deal anything at all with the values on here, but this idea of ranking acids, being able to tell if something is strong or weak, if it's an acid or a base, it's all information that we can pull right out of the data booklet, right off of this table. I hope that helps.